Hello, this is Pat Lynch, and you are listening to the Career Pathways Podcast, a podcast where we talk to a whole bunch of interesting Lyon faculty and some staff about careers, and also get to learn about what subject they teach and just a little bit more about them in particular. Today we have Dr. Eric South. He is a professor of biology here at Lyon. Been here 3 years, done an awful lot, and I'll leave it there, and he can explain all the rest. As always, joining our podcast is my co-host. And your name, sir?
Gavin Brunson.
All right. And also, behind the board, making the magic happen, the Ayatollah of rock and roll himself, producer Jayson. Say hello, Jayson.
It's producer Jayson. Hello.
All right. Well, real excited. Hello, Eric. How are you?
I'm good, thank you.
Oh, wonderful. Well, this is a kind of we start out, and this is a podcast about careers, and we'll get into that in a moment. But firsthand, kind of start out and tell us about yourself, kind of where you're from, where you went to school, and kind of what path it took to lead you here to Lyon College.
I'm from Atlanta, Georgia, and I grew up just north of there in Kennesaw, Georgia.
Yep.
I've actually had two career paths. The first was in music, and I earned 2 degrees in music. The first was a bachelor's degree from Virginia Commonwealth University in Richmond, Virginia. And then I earned a master's degree from the University of Tennessee in Knoxville, Tennessee.
Yeah.
After earning those 2 degrees, I performed as a musician for about 2.5 decades in the Atlanta area. And then I went back to school and studied science. And I got a Bachelor of Science degree from Kennesaw State University in Kennesaw, Georgia. And then I got a master's and PhD in entomology from the University of Illinois in Urbana-Champaign.
And entomology is the study of?
The study of insects.
Insects. All right. What was that moment when you said science is right for you? That there's something that I just found this to be something that is perfect for me. Was it like a moment, or was it a series of moments?
I'd say that goes back to childhood. I've always been interested in science, especially in organisms. As a child, I recall exploring streams and woodlands and catching amphibians and reptiles. And so I've always been interested in biology and organismal biology. And I took a detour with the music for almost 3 decades. And then I decided, well, let me give science a shot, because I've always wanted to do that. So that's what I did. And
then, one thing as far as this being a podcast about careers, we always kind of start out with, here it is a Lyon student that's a biology major, and say it's a Lyon student with a biology major interested in entomology. What career paths are available for that student? Kind of what options do they have?
Well, there are a lot of options. One, of course, is to go the academic route, and you can teach entomology. You can teach at the college level, entomological courses, not only with the taxonomy and evolution of insects, but also their importance to humans in terms of agriculture. And you can also work as with industry. You can work as a consultant in entomology. So there are a lot of different options in entomology.
With industry, would it be like working for Monsanto or something?
Exactly. If you were developing a certain insecticide,
right.
Sure,
So it's not it's not their bugs aren't your friend. So, no, just a thought. Why is studying entomology so important? In terms of that, and it has a definite place in biology and importance. Why is that?
Well, insects are very important to humans, for one thing. I've heard that, well, we can't live with them and we can't live without them.
Mm-hmm.
We can't live without them because they're pollinators, and we need that service, that ecosystem service of pollination for our own food supply. There are pests, so that's a problem in terms of agriculture, our own crops. They can be nuisance pests as well. They're important to humans, extremely important. They're vital to the ecosystem, for one thing. So a lot of different reasons to study insects, not just the fact that I find them very interesting.
Yeah, talking with Cassia Oliveira previously, she was talking about the evolutionary, as far as the evolution of genetics and just how insects have been basically on the planet, like for I can't even quote the number of years, but how it all evolved. Do you study that at all, or do you?
I do, and I especially study the evolution of aquatic insects, since that's my specialty.
Right.
Going back before the Carboniferous, 350 million years ago and prior to that, we have ancient lineages of insects. With the stoneflies that I study, they date back to the late Carboniferous, some of their ancient relatives, and they're part of the insects called hemimetabolous insects that have an incomplete life cycle. So they don't have a pupal stage. And those insects predated the holometabolous insects that have a complete life cycle by about 100 million years. Yeah.
So is it true? I just want to ask, is it true that insects were actually bigger in the past, like during like the Jurassic?
There was a period when the insects were much larger than they are today. That is true. Yeah, with some of our fossils show probably a wingspan of close to a meter for some of the dragonfly-like insects.
So the stonefly that you studied today dates back to prehistoric, like even before what we would call prehistoric time.
Yes. Yeah.
So, because y'all, I guess being the business major, and not having that surface level knowledge that you always think of everything that was prehistoric became extinct, and that's anything but the truth, right?
Well, more than 99% of all species that have ever lived are extinct.
That's reassuring.
I think somebody else said that. Maybe on the last podcast.
Yeah, Cassia said the same.
Okay.
Yeah, and well, it seemed depressing because it's like there's a sadness that that everything is eventually going to become extinct. I guess our turn will come when AI takes over, but
well, some say we're in the midst of a sixth mass extinction right now. There've been 5 mass extinctions, and some say we're in the midst of the sixth one. Yes.
Oh, ooh, this is taking a dark side. You mentioned your focus is about study is stoneflies, the insecta. Oh gosh, Plectoptera. Plecoptera. Okay, butchered that. Can you kind of tell us more about like your study and kind of what drew you to study stoneflies in particular?
Fly fishing is what.
All right.
That's actually what got me interested in the aquatic insects.
Right.
I've always been interested in insects, as I said, even as a child, exploring the woods and streams. Along with the amphibians and so forth, I was also catching insects, and I had fascination with beetles. But when I got into fly fishing as a teenager, I began to notice the aquatic insects.
Right.
And these are insects that spend part of their lives in the water.
Right.
So stoneflies are aquatic insects because for most of their life, they're actually in the water. Then they emerge as terrestrial adults with wings. And as a fly fisherman, you imitate what the trout are eating, which a lot of that has to do with, the insects that are the aquatic insects. So I began to tie flies because I only wanted to use my flies when I'm fly fishing. Yeah. And I was noticing the insects a lot more at that point. And I was noticing every detail of their anatomy and morphology and trying to imitate that with my flies that I was tying.
How do you movement across the water to imitate kind of how they'd behave?
Well, in terms of tying the fly, you want to try to imitate that particular insect as best you can with the materials, the color materials, the size materials, and then you want to present it as naturally as possible. In most cases, it's the adult. If you're talking about dry flies on the surface, they're just floating naturally with the current. And if they're subsurface flies, then you would imitate some movement.
Oh, got it.
Yeah. But stoneflies I found particularly interesting because I just liked the way they looked.
Yeah.
Some of them are rather large.
Yeah. So within stoneflies, is there like a series of like families or because stonefly is probably a general term, right?
Right. That's just a common name.
And then there's like how do you break out like as far as the family or the different species? This is a business major talking, so help me here.
Yeah, there are actually 17 families of extant stoneflies.
Right.
And I was fortunate enough to work with some colleagues at the University of Illinois, where for my PhD research, we actually elevated a genus of stonefly to the 17th family. So Cathoperlidae, and we were very excited about that.
That was a new discovery of so there were previously 16, and now that you found...
Right, yes, previously 16 families, and now we have 17. Doing molecular analysis, we found that this particular genus warranted a classification at the family level and not just at the genus level.
How does that get officially? How does that you go about getting that officially kind of acknowledged in like academic circles, or if the government plays a part? What's the process to formally recognize that 17th family?
Yeah, well, after you've done your research, you need to publish it. So it has to be peer reviewed, and so other stonefly experts reviewed our manuscript. And
they're a brutal bunch.
They can be.
Oh, okay, I'm sorry.
So you have to get approval of your peers, and then it's published by a reputable journal. And so we got it published, and then the zoological International Society has to approve the nomenclature and that that the name is valid and so forth. Yeah.
Wow. And then how long does it take for that to get into kind of academia, like with biology professors, teaching entomology, that now they revised the curriculum and that there's actually 17 families? Yeah.
And so once you get the publication, that's pretty much when it's accepted at that point by the community. So it was accepted very shortly after that publication. Yeah.
Wow.
And one of my former professors who teaches entomology, I think he included that in one of his textbooks, the very next edition, that there are now 17 families.
Well, that's quite an accomplishment.
Well, we were very excited about it. Yes.
So you partnered with a couple
colleagues at that time, our academic advisor and some other professors there at the University of Illinois, as well as some graduate students. It was a whole team of us, and as well as plecopterologists around the country. I think we had 10 or 12 authors on the paper.
Yeah. Now, is that finding a new family? It just seems that's to me it'd be a big deal, because you would think we know all about the as far as like just say the whole insect.
Oh, we don't.
Ecosystem.
We're constantly describing new species. Of course, that applies to all taxa.
Really?
All groups of organisms. Yeah, there's so much more to be done in terms of describing species.
With all the research methods, technology we have, how is it that we're constantly discovering new families? Is it just that they're not visible, or there's just the detection methods we use aren't? I mean, both of that actually. Yeah.
A lot of them are not that conspicuous, especially in areas that haven't been explored that much.
Right.
And also, we have molecular techniques now that we didn't have available to us a few decades ago. So a lot of our species descriptions and taxonomic groupings are based on molecular evidence, DNA.
Yeah. With finding a 17th family of stonefly, going back to that talk about extinction. So stoneflies would you consider them like a thriving species versus a declining? Because I would guess that something in the decline you wouldn't find new families.
Yeah, it's interesting. You mentioned, are they declining? And actually, we are losing species of stoneflies. And one reason for that is they are sensitive. They're environmentally sensitive. And so those of us that study stoneflies, we are concerned about the loss of species.
Yeah.
That applies to a lot of other different groups too.
Yeah, because I remember when you did your colloquium, what stuck with me was kind of how your study, as far as stoneflies, gives you insight at a very granular molecular level in terms of the impact of climate change. Because between climate change and just all the other changes in the environment, you probably see that via the stonefly. Yes.
Oh, definitely, yeah. Being sensitive, and they are actually the most sensitive of the aquatic insects.
Yeah.
But I also look at other groups of insects, aquatic insects like the mayflies and the caddisflies. In fact, you can group those three groups of insects, orders of insects, collectively. We call them EPT.
Okay.
And those letters stand for the scientific names, the Greek names for those groups, Ephemeroptera, Plecoptera, and Trichoptera. So the mayflies, the stoneflies, and the caddisflies. And collectively, because all three of those groups are sensitive, environmentally sensitive, sensitive to pollution and degradation of habitat, we can use those to monitor the health of our lotic systems, our stream systems.
So with environmental sensitivity, what is it that is a particular danger to these species?
Humans.
Just in general, yes.
Well, human impact, yeah. Loss of habitat and the degradation of habitat, largely from anthropogenic influence. So that's a concern of course, to the biologists in general, not only to entomologists, but we're concerned about that.
Stoneflies are freshwater?
Yes.
Okay, so mainly rivers, streams.
Yeah, mostly rivers and streams.
Okay.
Yeah.
And then what do you see the environmental impact occurring in rivers and streams around us?
In the local area?
Yeah, I guess local area or just in general that would endanger the stonefly.
Yeah, so some of the activities that agriculture, for one, urbanization, industrialization, all three of those
and
impact.
Agriculture is kind of like fertilizer, pesticide runoff into
Exactly,
the water?
yeah,
Okay.
getting runoff from fields and those pesticides that are applied to our crops, they're extremely toxic to aquatic organisms and the insects that are there.
Yeah, because you must have, if you've ever been down to Florida and you see what red tide is, that is frightening. When you think, because a lot of that's from fertilizer runoff.
If you're talking about red tide, you're talking about a protus that actually goes through these blooms and some of that, yeah. But generally, I'm speaking about.
Well, there won't be red tide in the freshwater, but it's just the impact of what you think. What's the big deal? It's just fertilizer, but when it runs off,
and
the outcome is
and we get an excess of nutrients is the problem. We get too much nitrogen, too much phosphorus in the water, and that promotes algal growth. And then that algae has to eventually die, and then when it's being decomposed by the bacteria, oxygen is consumed, and you get an anoxic or a hypoxic situation, low oxygen levels, and that's detrimental to the system.
With climate change, a lot of talk about the planet getting warmer, and a lot of it's about ice caps melting, ocean levels rising, oceans getting warmer. But do you see that as much in rivers and in streams as far as elevated temperatures, or is it still relatively constant?
Yeah, I mean that's climate change is definitely a factor for streams and rivers. rising temperatures. Of course, you're getting rising water temperatures, and a lot of these organisms evolved in cooler temperatures, cooler water temperatures, if we're talking about streams, and that's definitely affecting their life cycle and even their survival in some of these systems. Yeah.
So they're where the stoneflies, where it's like families are being endangered, and it's all due to the environmental impact, or is there something else that's occurring?
It's largely due to that, human influence. In terms of what we're seeing with loss of biodiversity. And of course, there's always a natural rate of extinction or that occurs, and then if we reach periods where we have an elevated rate of extinction, and that's when we're talking about the mass extinctions.
Right.
And we're perhaps in the midst of another one right now because of this increased rate of extinction.
Like, who's the primary predators of stoneflies?
Natural predators.
Yeah, natural predators.
Fish, salmonids, and birds eat some of the aquatic insects, amphibians.
So they have a lot of friends.
Other invertebrates too. Yeah.
So is that population remaining stable? Because sometimes,
which population?
The stoneflies, natural predators. Because sometimes, if natural predators are declining, that might elevate their population. I'm thinking simplistically, like the deer population. Sometimes you hear about, just that it's, all of a sudden there's less and less natural predators, and now
it's all interrelated. Yeah, you're right. It's all interrelated when we're talking about ecology.
Yeah. So, kind of when you look at ecology and what impact it has on the stonefly, are there natural predators remaining? Are they increasing, stable, declining, or it's kind of hard to say?
I don't know if the stonefly populations are directly impacting their predators. That's a good question.
Yeah.
Which I'm not, but I'm sure there's got to be some impact.
Yeah. What you mentioned, like aquatic insects. What are other aquatic insects that, like, just the general population would know?
Other than the three I've mentioned. Dragonflies.
Which
we have lots of those around here. Even on campus, you can see them flying around in August. The damselflies. Of course, there are things like mosquitoes.
That's an aquatic?
Sure, because they have a larval stage that's aquatic.
Right.
Yeah.
Okay. Is there anything good for a mosquito? It's like, seriously, is there? Because they carry disease.
Exactly.
Thank you very much. Obviously they can sting and be uncomfortable. I can't think of much that's good, and of course it's an ecosystem, so they have to play a positive part somewhere.
They do. They are a food resource for a lot of animals, for one thing. Another is you can think about, they carry disease, and that's true. A lot of them transmit disease pathogens to mammals, and in the process of doing so, they can actually control mammal populations.
So nature's hitman in a way.
Yeah, you could think of
silent killer.
But because I think you, with study entomology the way you did, I'm sure you have a much deeper respect for like the environment and kind of development and kind of where we're going with all of this. Because I just read like the Biden administration's trying to make a lot of changes in terms of how we responsibly use federal lands, trying to pull back on this push over decades for development and trying to look at things a little differently. And I mean, you're I'm sure aware of all that, but it's because there's things like environmentally that I just casually I would never see, where I'm sure you're aware of it every day.
Most definitely. Most ecologists are aware of those issues. Environmental scientists even more so than ecologists.
fascinating. The Gavin, anything? I've been kind of dominating the conversation, but anything on your side?
I just want to go back on the mosquitoes. So in like I guess everybody's eye, mosquitoes are pests, right? So would you say that stoneflies could be labeled under there, like as a regular person, every day looking at it, could they be labeled as pests or no?
No, yes,
No? Okay.
we would call stoneflies beneficial insects. Stoneflies do not bite.
There you go.
Yeah.
Why are they so attracted to running water? Like, because you mentioned that it's only like they are around streams and like these river basins, but why aren't they like more so around like what makes the running water so?
Yeah, well, running water typically has more oxygen, more dissolved oxygen, especially cool running waters, because cool water can retain more oxygen. So their larval forms, their nymphal forms, require lots of oxygen. So they need well-oxygenated, cool water. Yeah.
Over all the centuries stoneflies been in existence, how have they evolved? Like we were talking about that it may have been larger at one point, but is there other things like is there any crossbreeding with other aquatic insects or any things that have just taken place over centuries and hundreds of thousands of years?
Yeah, well, there's always hybridization with almost all lineages of animals. But yes, they evolved as aquatic insects. As I said, of quite ancient order. And as I said before, they're hemimetabolists, so they don't have a complete life cycle. They do not have a pupal stage.
Right.
And those insects, appeared in evolutionary history before those that actually do have a pupal stage.
Pupil meaning eyes, or being able to see it? Or?
Like a pupa.
Okay.
Most people think of a complete metamorphosis. They think of a butterfly.
Got it.
Yeah.
Right.
Yes, and then they form that.
Jayson trying to show off his science knowledge here.
One class about yourself.
Yeah, he did take a introductory course.
There he is. Yeah. I hope you gave him a bad grade, but no.
I had a good grade.
You know, one thing I remember also from your colloquium was, just the students went out and captured a whole variety of insects just in this general area. And I was surprised at the number that you could, without having to even go very far, just go by in the woods around us. I mean, that's I guess no surprise to you. Is that very common that there's just our ecosystem it has an amazing number of insects?
Yeah. So are you referring to my entomology class that I took, or the research students that?
The research student, yeah.
Okay, yeah. So we went to some of the streams locally.
Yeah.
And I think the students ended up identifying over 1,000 specimens just from three streams,
right?
From three visits.
And just here, without really, it's still just mind-boggling because
students are always amazed anytime I take them in the field.
Yeah.
And if we go to a stream, and we'll take what's called a dip net, put it on the bottom of the stream, and just disturb the substrate immediately upstream of the net, and allow the insects to flow and the other macroinvertebrates into the net, and then we'll dump it into a pan. And you might have, you could potentially have 100 specimens right there in that pan from just less than a square meter of stream bottom. Yeah.
It just shows how amazing this world really is. All right, dramatic change of subject.
Okay.
Music. Yeah, you mentioned that, and we talked Friday as far as, a little bit about music. Kind of what music are you, you're a performer still, or do you?
I still perform. I don't have the time to devote to performing like I used to. But
and your instrument is?
Primarily saxophone, primarily the tenor saxophone.
Tenor sax,
yeah.
All right. So you're following the great line of tenor sax players. Kind of who are your influences?
Well, when it comes to tenor saxophone, I'd say John Coltrane.
Yep.
But others as well, all the way back to Lester Young and Ben Webster, Joe Henderson, Sonny Rollins. There's so many tenor saxophones. Dexter Gordon. and others. But I started out as an alto saxophone player.
Okay.
And so I used to listen to Charlie Parker. And Johnny Hodges and Cannonball Adderley.
Mm-hmm. Yeah. So, but you still just, do you play like just practice at home or?
I do practice every week. I wish I could practice every day like I used to. I don't have that time, but I try to practice 2 or 3 times a week just at home.
Yeah. What drew you to jazz as far as a music form?
I heard John Coltrane.
Yeah.
And when I first heard him, I was more or less mesmerized by that sound that he got. And at that point, I said, I want to do that.
Wow. Yeah. Yeah. Which album was that?
It's Blue Train. And
Blue
I
Train.
was listening to the
yeah.
title cut. It was actually, do you remember H. Johnson from Atlanta who had a radio program?
Oh, yeah.
He played Blue Train one night. It was a Saturday night program, and I heard that.
Boom, yeah. Yeah, my introduction was, one, I was going to the University of Michigan. They had the Ann Arbor Blues and Jazz Festival, and they'd roll in all these greats. And so I just would be there, and I could, just listen to a Sonny Rollins because he would be right there on campus. Right. And one by one, then you grew that appreciation, and you realized, what a great art form it is. Now, I take it that if you're a jazz musician, you improvise?
Yes.
All right. Yeah.
That's a must.
Yeah, it's a must. Yeah, absolutely. The and you read? You can read music?
Yes.
Yeah. So, because some of the greats, could Coltrane read or Charlie Parker?
Most of those musicians, yes, could read.
Yeah.
But you're right in that a lot of the great jazz musicians learned purely by ear.
By ear, yeah. I mean, Miles Davis, he went to like prestigious academy. I mean, he went to
Juilliard just very briefly and dropped out.
Yeah.
I wanted to spend time with Charlie Parker on 50.
Yeah, hanging out. But that's amazing. Gavin, any kind of final questions?
With the saxophone, is it considered a woodwind or a brass instrument?
It's a woodwind.
It's a woodwind. Okay.
It uses a cane reed, which I think is why they refer to it as a woodwind. Yeah.
Sure.
All right. And how about you, Jayson? Anything from showing off your science knowledge again?
No. Did you teach music though?
I did.
You taught like bands?
I taught private lessons. I did some master classes for a few bands. Yes.
And you weren't like in Whiplash where you're like, beating them.
You've seen that? Yeah.
I have.
Yeah.
You weren't like that though?
Was I a teacher like that?
No. I'm just messing with you. But yeah. No, I mean, I don't really have anything else to say. Oh, I was going to ask. Okay, so if mosquitoes were to go extinct, would the things that consume them, like that, is there anything that like solely relies on it? Like if mosquitoes went extinct, the other things that eat mosquitoes would just perish too. Like they would slowly die out, or would they evolve to eat other things? Because you mentioned that like they're a food source,
right?
But like let's say like humans like found a way to just beam them out of the world, right? And they were gone. Would it? How badly would it affect the ecosystem? Really?
It would affect it. Case in point, dragonflies. They eat a lot of mosquitoes, and so if you remove that food source, it's bound to affect their survival and reproduction. And so we could have if all the mosquitoes went extinct overnight, eventually we would probably see another predator evolve that would rely on another food source, or we might see the evolution of a change in the dragonflies. But the dragonflies, as we know them, would be different.
Yeah. Well, it's all like that's the whole thing with the ecosystem. Everything's connected, so it seems simplistic. Let's just get rid of mosquitoes. They're a pest, but you don't realize just how everything connects. And
right, and you could have what's called ecosystem collapse, where the ecosystem changes so dramatically, the character changes permanently, and it never reverts back to its original state.
And then could that, in theory, like let's say like mosquitoes went extinct, right? that could mess it up so badly that other things go extinct, and then those things, and it like could just cause like a chain reaction.
Yeah, a cascade, exactly. Yeah.
And then, so you mentioned there was 5 major extinctions, right? We're in our 6th supposedly. What were the 5 major extinctions? Do you know?
Ordovician, Devonian, Permian.
You could say anything and we'll agree.
Triassic and Cretaceous, I believe.
There, you passed the class.
Got an A.
Yes, well, I think that's a great way to close this podcast out. Eric, thank you very much. You've been a great guest. And this is Pat Lynch. Before I say goodbye, I have my co-host.
See you.
All right. And way back there at the board.
See you guys. And yeah, you can find the Career Pathways podcast on 99.97% of platforms, the same number of terms like KILT.
There you have it. We started with science and we're going to end with science. So once again, this is Pat Lynch. And thank you very much for listening to the Career or watching the Career Pathways podcast. We hope you join us each and every week. And we look forward to seeing you again. Take care.
This broadcast is sponsored in part by Lyon College and by KILT Studios.